And the third question. Okay, so we got PQRS is a parallelogram. I went ahead and highlighted it. I know my drawing does not make it look like a parallelogram. Anyway, we got PR and QS intersect at T. That's very important, the word intersect. Okay, please, it is not the same thing as bisect. Intersect means that they just meet. Bisect means that they meet and cut each other, and when they cut in each other, they are exactly in half. Intersect does not mean that. Okay, you can cut one part small, the other part really big. Okay, right? QT equals RM. I went and highlighted that, equals RM. I also know that because this is a parallelogram, QT equals DS. Because diagonals are equal. They bisected, not equal. Diagonals are bisected in a parallelogram. SM equals PT, so there's it. SM equals PT in yellow, but I also know PT equals RT because diagonals are bisected in a parallelogram. The first question says, prove that RTSM is a parallelogram. Highlighted that in this pink color, right? And just by using my colors, you can see already the side and the side are equal, the side and the side are equal, therefore parallelogram because opposite sides are equal. Now let's go ahead and write that down. Okay, so okay, how do we know that RTSM is a parallelogram? The reason for this is because we proved this and this are equal, this and this are equal, which is exactly what I wrote down over here and explained to you earlier. Okay. If you left out the word of quad are equal, of quad, that's fine. You could have just said opposite sides are equal. Here we go. Or you could have even said both pairs of opposite sides are equal. That's perfectly fine as well. And there we go. That's proven. Makes it so, I know I'm repeating this over and over. I want you to understand how important it is to use color pens. It makes you see the answer so much clearer. Okay, next question. QR equals to RN. All right. I went and highlighted it over here. Right, and then they gave us a hint that we need to prove that PQR is congruent to SRN. So I just redrew the diagram so that I can highlight those two parts. Okay, wait, let's use a different color. A second. Okay, PQR, I'm going to highlight and use the hint. Okay, PQR Where's that? PQR, this one here. Okay. Right, we need to prove that that triangle is congruent to SRN as this one over here. Okay, that's what we need to prove. Now remember I mentioned in my first video that for congruency there are four different ways. The first one being RHS. Okay, is there any right angles in either of these? No, there isn't. Okay, so that's eliminated. Okay, then there's sides. Okay, which is what we're looking for. We want to prove that this one here is actually equal to this one. So since we don't have information about one side, okay, we can eliminate side. Okay, so that one's out. So that means we're left with side angle side, or else side angle angle. Okay, before we decide which one of those we want to use, let's fill in all the information about those two parallelograms that we know. Okay, so this was the parallelogram over here, PQRS. So in this diagram over here, if this is the if this is the parallelogram, we know that this whole angle over here is equal to this whole angle over here. That's not very helpful to us. Okay, we know that this whole angle over here is equal to this whole angle over here, opposite angles being equal, right? We know that, what else do we know? We know that the sides are parallel, so that means, let's draw the Z. Okay, you see the Z with me? This angle would be equal to this angle. Okay, not helping us so much yet, but let's fill in the rest. If we draw the Z in the other direction, okay, we know that this angle here, let's do that, is equal to this angle over there. All right, let's see what other information we have. Drawing the angles the other direction, that way, we get that this one here is equal to this one over here. Okay, we also get the other direction. Oh no, sorry, this direction. So I'm going from PQ like that. So this one over here is equal to this one over here. Okay, let's see in that other quadrilateral that we were working with if we can link any other information with regards to angles. Okay, oh, hold on, we forgot to mention something else. Let's fill this part in. This side here is equal to the side here. That's very important. Can you see it already linked something between the two triangles? Right. Okay, from this diagram over here, SMRT, we know that which sides are equal to each other that are going to help us. Okay, not really any sides, because if I use this side equal to this side, it's not helping the whole triangle, and if I use this side equal to this side, it's not helping my triangles either. Okay, so we know we're working with the angles. From opposite angles being equal, this whole angle over here is equal to this whole angle over here. Not really helpful to us, but we also know that this whole angle over here equals this whole angle over here. Again, not so helpful to us. We know that the sides are parallel, so this angle over here equals to this angle over here, right? Still not very helpful to us. Let's see which other way. Oh, this way here, going like that. We get that this angle over here equals, where did we go? This angle over here. Okay, and if you notice, using my dotted part over there, if this angle equals this angle and this angle equals this angle, we can conclude that this one and this one are actually equal to each other. Let's just do that for ourselves. So now we found something that's linking. Okay, then we need to get something else linking. Where is it? We've got side, we've got an angle, we need another side. Okay, I'm pausing for a second to see, because I have so many dots all over my diagram. Let me just see where my other linking part is. Okay, and I'm resuming, and I needed a break because, whoa, my colors over here were getting a bit confusing. I had to redraw my diagram to make sense of what was happening. And I realized something. They actually need a lot more than just proving that PQR is congruent to SRN. Because see what I did over here, right? And follow with me. I filled in all the angles that are equal like I did over here, just it was in green color. Okay, I just refilled it in, and then I went ahead and highlighted this one here being equal to this one here. Let's recap for you. So we said this one equals to this one over here, like I did over here. This one here equals to this one over here. Let's draw the Z again for you. Right, that and that are equal, and then in this side here, that's a parallelogram. If you go with the Z like that, this and this are equal. Therefore, we can conclude this one and this one are equal. So I filled it in over there for me. Perfect. Right? So we got an angle. Okay, we got that this side here equals to the side over here. Opposite angles of a parallelogram are equal. So I fold it in over there. If you look at our diagram, remember with congruency, if you were in my class last year, I explained it as identical twins, okay, to make you guys understand it a bit better. And we said that they are exactly the same, okay, so that means the angles are exactly the same, the sides are exactly the same. The only thing that happens in our questions, we turn them around. One is rotated the other way around, or translated, or reflected, okay, that's what happens, okay. And if you look at this and this are exactly equal, this and this are exactly equal. Okay, so that means we need to prove either this whole angle here equals to this whole angle over here, or this whole angle over here equals to this whole angle over there. That's what we need to prove, either one of them. Okay, so that we got side angle, angle. Now if you look very closely to our diagram, and this one here as well, with our colorful angles being equal, we prove that this angle over here, this part of it over here, is equal to this part of it over here, right? Using the Z. Follow with me. That is it. Okay, and then if we in this parallelogram over here, right, let's make a Z. It's this angle over here. So basically this one equals this one equals this one over here. So I have it in this diagram as well. There it is, equals this one over here, because they're all equal to each other. Okay, that means I need to prove that this side here is basically equal to this angle over here. And I got a bit stuck with that. I was like, no way I can do something like that. Makes sense over here. Follow with me. R to Q to S to P. This is Z. Follow my pen. So this angle equals this one. But there's no way I can link this to be equal to this part over here. Okay, using this parallelogram. Which is when I realized something. Can you see that there's actually a big parallelogram over here? NRPS. Now you're wondering, how on earth can we prove that that one is a parallelogram? Okay, remember from our 5 things we said about a parallelogram, one of them is that opposite sides have to be parallel, or else opposite sides have to be equal, right? So this side here, MS, is parallel to RT. Therefore, NS, which is the extended line, is equal to RP, because they're all on the same straight line. Okay, so let's write that down. NS parallel to RP. Okay, MS parallel to RT, opposite. This is going out of focus. Okay, here we go. Okay, and remember in this big parallelogram, RQPS, so the big one over there, this side is parallel to the side over here. Let's go back to our original diagram that's highlighted in green for you. Here's the parallelogram. RQ is parallel to SP. Okay, so if RQ is parallel to SP, do you agree with me? This whole line is basically parallel to SP. Therefore, we can conclude NR is parallel to SP. So let's write that down. NR parallel to SP. How do we know this? It was because RQ is parallel to SP, opposite Therefore, NRPS is a parallelogram. And the reason for this is opposite sides are parallel. Okay, opposite sides are parallel. We just wrote that down. So if this one's a parallelogram, now let me highlight it in a color. Let's go with this. This part here is a parallelogram. That makes this whole angle equal to this whole angle, isn't it? Right? So let's follow that in over here. This angle equal to this angle. And isn't it we know that this angle over here, follow with the Z, is actually equal to this angle over here. Okay, because of alternate angles. Therefore, this angle is equal to this angle is equal to this angle. They're all the exact same angle. So let's fill it in over here. This part is basically equal to this part. And that's exactly what we needed. We can now prove that those two diagrams, those two triangles are actually congruent. And by proving that they're congruent, we can prove that this and this are equal. Or alternatively, I just realized something now. We don't even have to prove that they are congruent. If you think about it, we know that this here is a parallelogram, so therefore opposite sides are equal. If this and this are equal, and this are equal, then this and this have to be equal. So, wow, I realized something else. I'm going to write down both of the solutions for you, okay? So the first one, which is the easier one, which I just figured out right now as I was working through this, we can say RQ, so R is here, Q is here, S, P, and N. RQ is equal to SP. Okay, and then NR is equal to SP. Therefore, not parallel, they wanted it equal, and it is equal. RQ is equal to NR, which is exactly what I wanted. RQ equal to NR. There we go. Okay, using the other way that I said, using the whole congruency thing, we're going to have to turn over. Sorry, it was in triangle PQR and SRN. Right? Oh, we're going to have to keep turning over and over. Maybe I should be writing on a separate page. Let's do that. Okay. So we proved that PQ is equal to RS, and the reason for this was opposite sides we proved that I'm going to explain this in a second. Okay, let's explain what I did. Oh, therefore, okay, let's take it from the top. So what did I do? I said in those two triangles, so this one over here and this one over here. And then if you remember in the original diagram, they actually had numbers for them. So that's what I was doing with these numbers over here, okay? So I said that PQ equals RS. We discussed this already. This equals this because they're opposite sides of this parallelogram, okay? Then I said P1, which is this one over here, equals R3, I think it was. Yes, this was R3, and this was because of the Z. So alternate angles, and then I wrote down which lines are parallel and how do I know that they parallel. I did the exact same thing for S1 equal R3. Let's go back there. This was S1, this equals R3, and it was because of that Z, right? And I wrote down which lines are parallel and how I know that they parallel. Then I drew my conclusion because these two are exactly the same angle, therefore this one and this one are equal. I did the exact same, no, wait, it's a bit similar. I said angle R equals angle P2. So here we go, angle R3, it was R3, I think. No, this angle R over here, which was angle R4, let me fill that in there. R4 equals angle P2, which is this one over here, right? And this was again because of the Z. I listed down which lines are actually parallel, how I know that they are parallel. Then I said this angle over here, which is P2, equals to angle N, because remember we discussed that this thing is a parallelogram, opposite sides being equal of a parallelogram. That's what I wrote down over there. If these two angles are the same, these two angles are exactly the same. Let's list that down. Therefore, I now have all the information. So this and this are the sides, this and this are the angles, therefore side angle, okay? So I can prove that those two shapes are in fact congruent. And if they're congruent, that means everything about them is identical. I can prove NR equals RQ, which is exactly what they wanted from me. That was a very, very long way to get to the answer. Okay, I hope that you guys can practice this and you can try this and you can do this on your own, because these are the types of questions you're going to be getting in your test. Good luck.